So in this section, we're going to introduce you to a new system of numbers called the complex number system. So let me give you just a little bit of background about this. So it turns out that in the 16th century, there was an Italian ballistics expert who was working on trying to solve some quadratic and cubic equations. The quadratic equations, they're modeling the behavior of projectiles in flight. And actually, in chapter 9, you're going to be looking at some of these quadratic equations, and you will see how they can model the behavior of rockets and projectiles. There was a problem. He was needing to solve quadratic equations that required them to take square roots of negative numbers. He and other mathematicians were looking at these equations, and they realized, gosh, in order to be able to solve these equations that are modeling my behaviors here, I need to be able to take the square root of a negative number. So they went ahead and invented a new number called I. They called it I, and this is not a real number. It's an imaginary number. And how they defined I was that when you square I, so I squared is -1, which means that I is the square root of -1. And then they went ahead and used that imaginary unit I, and they created a new system of numbers called the complex numbers. And the complex numbers look like this. They have a real part. So here's an example. A real part, let's say the number 2, added to an imaginary part. Let's say 5i. And notice that you would use that I is there, right? And that I, as you recall, is defined as the square root of -1. And so, although we're not going to do a lot of work with complex numbers in this course yet, you may find it interesting to know that even though it was the 16th century when they were inventing I and talking about I, wasn't until they got to the modern electronic age where they really saw the application of these complex numbers, because it turns out that the complex numbers are really, really useful when you're analyzing anything that comes in waves, such as electromagnetic radiation that are used in radios and Wi-Fi, audio signals for music and voice communications, and indeed, quantum physics reduces all particles to waveforms, so complex numbers were really instrumental in understanding things such as GPS and MRI imaging and other things. So imaginary numbers, they are useful, and we're just going to work with those imaginary numbers now. So we're going to use them to simplify square roots of negative numbers. So take a look at our first example here. And it's asking us to evaluate the square root of -16. So it says express it as a complex number in terms of I. So you've just learned that I is the square root of -1. So we're going to take that -16 and we're going to split it up. We're going to write it as -1 times 16. And we're going to take the square root of -1 times the square root of 16. And that's going to be how we're going to evaluate or express the square root of -16 as an imaginary number. So we're going to replace the square root of -1 with this I, and then the square root of 16 is 4. And now, interestingly, we'd like to put the 4 in front of the I as a coefficient. This number, square root of -16, can be expressed as a complex number or imaginary number called 4i. Number 2, you've got -5 times the square root of -64. So we're going to take -5, we're going to multiply it times the square root of -64. But first, we're going to take -64 and rewrite it as square root of 64 times the square root of -1. And the square root of 64, you know, is 8. And the square root of -1 is I. And we have to multiply by a -5 that was already there. So this complex number is -40i. Number 3, we have 7 plus the square root of -100. So again, square root of -100 is the square root of 100 times the square root of -1. And then we have a 7 plus that. Square root of 100 is 10. Square root of -1 is I. So we have 7 plus 10i. Now, this is a complex number in standard form. Let me go back and show you. So see that? Complex number in standard form looks like this. It looks like A plus BI, where A is the real part and B is the imaginary part. So see how this looks like A plus BI? So 7 is the real part and 10 is the imaginary part. And this is 7 plus 10i is an example of a complex number. So do not combine the 7 and the 10. 7 is the real part. The 10 has the imaginary I with it. So 7 plus 10i is your final answer. Okay, now we have the square root of negative 45. So we are going to break that up. Square root of negative 1 times, and then 45, we've done this before. That's the square root of 9 times 5. So we've got I here, we've got 3 here, and then we've got that extra square root of 5 that's left over, right? So square root of 9 is 3, and the extra square root of 5. So then you're going to see that you can combine this like this. You can put 3i square root of 5. You might see it listed like that. You might see it listed 3 square root of 5 and then I. But if you do that, be careful. I like to leave just a teeny bit of space here. Don't tuck the I under the radical, because that's a whole other math problem that we will not be doing in this level. Okay? So you can write it as either one of those. And by the way, these complex numbers that are single terms like this with the I, those are called pure imaginary numbers. That means that the real part is 0. Okay? As opposed to our last problem, remember it had the real part of 7? That's not a pure imaginary. Okay, square root of negative 48. So again, we're going to break that up. Square root of negative 1 times square root of 16 times square root of 3. 16 times 3 is 48. This is a I for the square root of negative 1. This is a 4. And then we have square root of 3. So 4i square root of 3. And finally here, 9 minus the square root of negative 108. 9 minus the square root. Okay, so we got to do something with this negative 108. Square root of negative 1, it's 4 times 27. And 4 is a perfect square. 27, 9 times 3. So we have, for the square root of negative 108, let's write it here. We have the square root of negative 1. We've got the square root of 4. We've got the square root of 9. And we've got the square root of 3. Right? Because we have the 3, the 9, the 4, and then the negative 1. Okay, so this is an I. This is a 2. Square root of 9 is 3. We're going to multiply all these, and square root of 3 is left over. So we have 6i root 3. 6i root 3. So up here, then, we're going to bring this down. 9 minus 6i square root of 3 for our answer.